All right, pre-calc, we're moving on to chapter 8, section 2, working on arithmetic sequences. We did do these in algebra 2. We are also working on partial sums. And our essential question today is, how do you find the nth term or partial sum of an arithmetic sequence? Well, the first thing we need to know is the arithmetic sequence formula. So let's go ahead and write that down. I know the word arithmetic sounds funny. Arithmetic. That just means it's being added or subtracted. All right, we're going to use the formula a sub n is equal to a sub 1, which means the first term, plus n minus 1 times the common difference. So this is the common difference. Meaning, are we adding 3 each time? Are we subtracting 5 each time? So this formula you will want to know. The first thing that they want us to realize is they just want us to see the common difference. What's happening between 5 to 8 to 11 to 14? Good, we are adding 3. And as you could see from chapter 8, section 1, we put that 3 right there. So now you might be able to just look ahead and see what's happening. From 9 to 5 to 1 to negative 3 to negative 7, what are we adding? Good, we're adding a negative 4 or subtracting 4. And from 1 to 7/6 to 4/3, if I didn't reduce that and it was over 6, wouldn't that be 8/6? If I didn't reduce this one, wouldn't it be 9/6? And 10/6. So is there an arithmetic sequence? And if so, what is the common difference? The common difference is we are adding 1/6. All right, so now we get to dig into the fun stuff. Find a formula for the nth term of the arithmetic sequence whose common difference is 5 and whose first term is, it would help if I could see this whole thing, -1. So I'm going to use the formula that I just showed you. We're going to use a sub n is equal to a sub 1 plus, a lot of people forget that plus sign, n minus 1 times the common difference. Well, I know the first term is going to go in for the first term, so this -1 is going to go in there. And I need an n in my formula because I'm looking for a formula with an nth term. And the common difference, they tell us, is 5. So all we have to do is distribute. So we get -1 plus 5n minus 5, and it looks like our formula is 5n minus 6. So I'm going to put that a sub n here, and that looks like the formula for this example 2. All right, we're going to get through a couple things that are a little bit more difficult, and I teach them a little differently. There's a ton of different ways to do it, so I try to teach it as sequences, or I try to teach them as systems of equations. So let's go ahead and look at example 3. It says the 8th term of an arithmetic sequence is 25 and the 12th term is 41. Write the first 5. So I'm going to write what I know. I know the 8th term is 25 and the 12th term is 41. And I have to write the first 5, but somehow I have to come up with a sequence. So I'm going to plug these into systems of equations. So if I'm looking at the 8th term, remember a sub n is equal to a sub 1. We don't know the first term, right? But we do know that this is the 8th term. So I do know that. I also know, I can erase this right here, that my a sub n is not a sub n, it was 25. Because the 8th term is 25, I could put that right in there. And if I was to solve this, I would get 25 is equal to a sub 1 plus 7d. Well, I'm going to do the exact same thing for the other term. Remember, 41 is equal to, we don't know the first term, but if I take the 12th term, well, 12 minus 1 is going to give me 11d. And now I can go ahead and solve this as a system of equations. So, good old Algebra 1 coming into play like it always does. I'm going to go ahead and change all the signs here. And I know that negative 25 plus 41 is 16. These a sub 1's will cancel out, which makes it so nice. And negative 7 plus 11d is equal to 4d. So you've already solved that the common difference is equal to 4. When I plug it back into an original, I always plug it back into an original here. 41 is equal to, we don't know the first term, but we know that d was 4. 41 is equal to a sub 1 plus 44. So I know that the first term is going to give me a negative 3, and it's going up by 4 every time. Well, let's go back to what the question said. The question said to find the first 5 terms. Well, I can't see it. So I know that my first term was a negative 3, and every time it went up by 4. So if it went up by 4, that would be 1. Up by 4 would be 5, 9, and 13. So again, we do have to use systems of equations. We're plugging it into the formula that we were given using the information that we have.